Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about the law of sines. So up until now we've been talking about right triangles, and I want to take a look at triangles that are not right triangles. They're called oblique triangles. So we are able to solve oblique triangles, but we can't use our trig functions in the same way we did when we had right triangles. I've got a general oblique triangle listed here. I'm going to call the angles capital letters A, B, and C, and then the sides opposite, so the side opposite angle A, I'm going to call small letter A. The side opposite angle C will be small letter C, and the side opposite angle B will be small letter b. One thing that we know about the angles in any triangle is the sum is equal to 180 degrees. And then there's a relationship between the sides and the sine of the angles corresponding opposite those sides. And that is called the law of sines. And it looks like this. If we take side A, the ratio of side A to the sine of angle A, that will actually be equal to the ratio of side B to the sine of angle B. It's also equal to the ratio of side C to the sine of angle C. Knowing this, if we know certain information about our triangle, we can find other information. Let's take a look at how we would use the law of sines to solve some of these oblique triangles. In my first example, I'm given two angles and a side, and with all of these questions, you're going to need to know at least 3 pieces of information about your triangle. I'm going to label my sides and my angles. You can label them whatever letters you want as long as the opposite sides correspond to the angles. So if this is angle A, this is side A. If this is side B, then this is angle B. And if this is side C, this is angle C. Because it's this side that I'm given, I need to know angle A to be able to set up my ratio, because I know these angles but I don't know either of those sides. So I'm going to start with the fact that my 3 angles add up to 180 degrees so that I can find A. So A will be equal to 180 degrees minus 75 degrees plus 65 degrees . Now that I've got angle A, which I know has to be 40 degrees, now I can use my law of sines to find B and to find C. So the way I'm going to start is I'll start with side A over the sine of angle A, and I'll find B first. It will be equal to B over the sine of angle B. So A is 10, angle A is 40 degrees, B I'm trying to find, and angle B is 65 degrees. So I'm going to isolate B. I'm going to multiply both sides by the sine of 65 degrees. And I will get a value of 14.1 units. In order to find side C, I'm going to use 10 and 40 degrees because this is a rounded off value, and whenever I can work with exact values, I would prefer that. So we're going to again use our ratio. So the side A over the sine of angle A will equal the side C divided by the sine of angle C. So 10 over the sine of 40 degrees will equal side C over the sine of 75 degrees. I'm going to multiply both sides by the sine of 75 degrees. You could have obtained this ratio first and then multiplied by the sine of 75 degrees. Just try not to round off as you're going through your calculations. Try to keep everything on your calculator. I like as much as possible just to write everything and manipulate, isolate my variable, and then punch in all at once. But it's personal preference. When I calculate this, I get a length of 15. So I have solved that oblique triangle. I found the missing angle and the two missing sides using the law of sines. Let's take a look at another example. All right, in our second example, we're given two sides this time and one angle. Again, I'm going to label everything. I'm going to label this angle A, so this will be side A. I'm going to label this angle B, so this will be side B. Angle C and side C. So I'm going to, in this case now, I'm going to use angle A and side A, and I'm going to use B to find angle B. So A over the sine of A will equal B over the sine of angle B. So 15 over the sine of 40 degrees will equal B, which is 12, over the sine of, I'm trying to find the angle. I need to isolate sine of B first, so I'm going to cross multiply here. So I'm going to get 15 sine of angle B equals 12 times the sine of 40 degrees, and then I'm going to divide by 15. So I can divide the whole thing by 15, or I can just divide 12 by 15 and then multiply that quotient to sine of 40 degrees. I am going to write a value here. I'm going to calculate this, and I will get 0.514. Now I want to find angle B, so I'm going to take the inverse sine of, I'm going to keep the value on my calculator. I've rounded it off to write it down, but I'm actually going to keep that value that I had on my calculator and go inverse sine of that. When I do so, I get an angle of 30.9. So I found angle B, which means angle C will be equal to 180 degrees minus 40 degrees plus 30.9 degrees. So C will equal 180 degrees minus 70.9 degrees, which will be 109.1 degrees. So I found angle C, I found angle B. I'm missing side C. In order to solve for C, I'm going to use what was given. A is 15, 40 degrees was given. I found my angle to be 109.1 degrees. Now I can solve for side C. Multiply both sides by sine of 109.1 degrees. And I obtain 22.1 as my length of C. In applications, you're going to be given units. So, I might have had meters here. When you attach the units, it's easier to see that it's a length. In this example, I was given the side opposite a given angle and another side. I want you to be aware that sometimes when you're given that information, you can have what's called an ambiguous case. If this side is the the side opposite the angle given is shorter than this other side that's given, there's 3 possibilities of outcomes. So in the next video, I'm going to take a look at the situation where this side is shorter than this side and show you what the 3 possibilities are. So practice what you can now, and then when you're ready, move on to the next video.